In this example, we're going to look at how we complete an exponential smoothing method of forecasting. As with all forecasting methods and trying to determine forecast accuracy, it all begins with the forecast itself. And with exponential smoothing, it requires us to remember a very minor formula. The formula itself looks a little ugly, but it's really not that bad when we start using it. So what this formula says is if I'm trying to predict for the next period, so t represents time, so time plus one period away from now, right? Y hat is the predicted sales, y itself is actual sales, is I have this thing called alpha, which we'll find out in a minute. That's our smoothing constant. We have our alpha value times actual sales from the current period times 1 minus alpha times predicted sales for the current period will predict our sales for future periods. So we're going to learn that as we change alpha, our prediction can get more or less accurate. So one of the things with exponential smoothing is to determine what is the optimal value of alpha that will get us to the best predictive method. To start, we arbitrarily set a value of alpha. And you'll find out why in a minute. We are going to have to cell reference this. So I'm going to cell reference to begin. I'm going to say that I want alpha to be 0.1. Much like many of the other methods, we can't predict for week 1 because we don't have any actual sales. And we see for this method, we need actual sales and predicted sales in order to complete this formula. The only period for which we make an exception to this rule is for period 2. We need to somehow get this process rolling with predicted sales from somewhere. So for period 2 and period 2 only, we're going to use actual sales for period 1, almost like the naive method of forecasting, to be our prediction for period 2. But now for every subsequent period that we have, we now want the prediction for period 3 to be alpha. And remember, I always want to reference back to this cell. So I want that absolute reference. So alpha times the actual sales for period 2 plus 1 minus alpha. And again, I want that absolute reference back to that cell times the predicted sales for period 2. So alpha times actual sales for the prior period plus 1 minus alpha times the predicted sales for the prior period. So if we hit enter, we get a prediction for period 3 would have been 4.596 or approximately 4,596 liters. Similarly, because we absolute reference our two alpha values, as we copy and paste that down, and I'm going to copy and paste it all the way down to week 13 because we will have to make a prediction for that in a minute. I notice that for week 4, if I highlight on that, again, all the alphas were referenced back to the cell with alpha, but as I copy and pasted one down, so now for week 4, again, we have alpha times the prior period sales, week 3's actual sales, plus 1 minus alpha times the predicted sales for week 3. So as we said, we get all the way down to a prediction at this point for week 13 of approximately 4,924 liters of gasoline. However, the one thing we don't know at this point is that the best option for alpha that we have. Remember, we just arbitrarily set that value for alpha. So in order to determine whether that is the best or not, we're going to first have to complete our measures of forecast accuracy. So again, I'll skip over this. If you need a refresher on that, please consult the 2.4 video in order to figure out how to do forecast accuracy. Now that I have my measures of forecast accuracy completed, I can go about determining how will adjusting alpha differentiate. Like if I was to switch alpha to the total opposite end of the spectrum, notice what will happen. Because I've cell referenced this all over the place, if I change this to 0.9, for example, I'll notice that my measures of forecast accuracy should all change as I change that alpha value. But which is the best? So if you remember back to Unit 1, we used a measure of sensitivity analysis within Excel. To start that, what we did is we wanted to tell Excel, change alpha values to these following values. Now in this case, we're asked to do it to 1 decimal place. So I'm going to say, make alpha anything between 0 its absolute lowest value, increasing by 1 decimal place at a time up to its highest possible value of 1. So there's all the possible 1 decimal options for alpha, from a lowest value of 0 up to a highest value of 1. How will that affect the measure of forecast accuracy I use to determine what makes a forecasting method the most accurate? And remember, our measure when we're dealing with the same scale and data is we want to talk about MSE. So if I adjust alpha to different values, how will that affect my mean squared error? So I want this cell here to equal this. And again, a cell reference to that. So what this function in Excel is going to do, without me being able to see, it is going to sub in all these values that I have here into, I'm going to tell it to sub it into this cell. And as you sub all these values into this cell, how will that affect the mean squared error in the end? So to make this work, we highlight both of these columns from my blank first column under alpha all the way down to the highest possible of alpha of 1, and also all the MSE column. Now we go to data. What if? So here our values are in a table. So we want a data table. And because our values are in columns, we're going to put that we have a column input. So in this column input cell, this is the cell that I want Excel to replace with these values. So I want Excel to sub these values into this cell here. And as I do that, Excel is going to put all those values into that cell and tell me how this cell was affected, because that's what I reference. I cell reference that cell right there. So if I hit OK, I can see that MSE changes depending on what it subs in for the alpha value. Well, at this point, this could be handy. It also gives me a little reminder when it's okay for me to express my final answers for MAE, MSE, and MAPE. And I'll explain why this little function will help. So what I want to do is go to Home. I'm going to select a conditional format, select the top bottom rules, and hit More Rules. What I want Excel to do is I want to do some special formatting when it finds the lowest possible value of MSE. Remember, low is good here. Low means less error, so I'm going to select the bottom, and not the bottom 10 values, but the bottom absolute lowest value. Now I'm going to give that any sort of format that'll make this value stand out. So format it in any way you like. I'm going to simply make it stand out with a yellow highlight. So as I hit OK, I see that it tells me the best possible value for alpha to 1 decimal place is 0.2. Now the reason why I highlight everything is because if I go and enter these values right now, these values for MAE, MSE, and MAPE are not based on having an alpha value of 0.2, which is told me to do, use the optimal value for the smoothing constant, or alpha. But if I change this, so I either type in 0.2 or I say I want it to equal 0.2, that lowest possible value, I'll get a reminder that my value, right, this top one is our value, the one that I have in right now, my value now also becomes highlighted, and when I see my value highlighted as the best possible option for alpha, now I know I'm good to go and enter my final answers of the best I can get for MAE is 0.68, for MSE 0.63, for MAPE 13.38%, and my prediction for week 13 would be approximately 5,067 liters of gasoline.